All right. So I now have the pleasure of introducing our next speaker, who is another person that I'm very fond of, Dr. Rich Vaia. He is the Chief Scientist of the Materials and Manufacturing Directorate at AFRL. He serves as the Principal Scientific Authority and Primary Authority for the technical content of the Directorate's Science and Technology portfolio. Dr. Vaia has been an ardent supporter of the regional network programs, and we're grateful for his time this afternoon. He's also one of the only chief scientists that still does research, which just makes me very happy. I will now turn things over to him so he can provide some information into AFRL and his directorate.
Thanks, Stacy. I'm going to start with something, a video, just keep everybody in mind that the regional networks are part of AFRL. So I'm going to drop my video off, but let's just jump right in.
Today's world is more connected and moves faster than ever before. But these technological advancements bring more threats to our way of life. With roots tracing back to 1917, the Air Force Research Laboratory continues to deliver technologies with speed, building on its strong foundation of scientific research and innovation to support our warfighters in defending our freedoms. Now, through streamlined processes, digital transformation, and a concerted focus, AFRL accelerates science and technology to meet the Department of the Air Force's priorities and prevail in the future. Supporting the Air Force and Space Force, we are one AFRL, one fight.
That video gets me pumped. That is why we're here. That is why we have an Air Force Research Lab. That is why we have the regional networks. We're all part of it. I mean, how awesome is it that we're part of this and this is what we're asked to do? Gets me stoked every day. So I want to begin by thanking Karen, Stacy, Eric, and the Midwest regional teams for bringing us together. Over 175 folks online, really exciting. As General Goodfellow said, the future's not waiting. The future has not been waiting. I mean, to some degree, we're just waking up to that. And we must continue to accelerate S&T while we navigate the current environment. The mission's enduring and it's unchanged. We have to bring power of S&T to the Air and Space Force for the joint fight. And key is to focus with conviction on what will transform, not merely what is new or disruptive. Transformational tech delivers a fundamental shift in the how, such that it changes the game to our advantage. It's not simply disrupting the status quo without a step function impact or solving bespoke issues to make current situation more efficient or sustainable. As General Goodfellow said, we just can't make things better. We got to do things differently. And so that's what I'll talk a little bit about for some of my comments here. We're all acutely aware that we are living in a time of change and consequence. There are numerous points to make on this slide, but I just want to highlight a couple. So the force posture the United States has been incredibly successful for the past 20 years. It was optimized to counter violent groups anywhere in the world with overwhelming force and technology. But our nation state peers have spent that same time observing our approach and developing counters such that our current force posture is not adequate to counter these urgent threats. And that was well aware a decade ago. Again, as General Goodfellow mentioned, there's certain situations where the United States doesn't win. And 2 decades of their investment in fundamental S&T, new concepts and production capability challenges our ability to keep pace. And that is the situation we're in right now. As for pace, I also don't need to recount to everybody the impact of AI, automation, and big data on our daily experience. However, the pace in the battlefield is even faster. Anybody who's been following situations in Ukraine, battlefield innovation resulting from providing the soldier with open source and modular tools have upended 75 years of thought on conventional force employments. Cheap drones are now making costly, heavy armor ineffective on the battlefield. The counter cycle for each new concept occurs in weeks now in Ukraine, not years. And it's unclear what this means with respect to delivering tools to the field versus new platforms to the field. We deliver platforms, that's year process. If we deliver tools, we'll allow the people in the front line to innovate and solve problems. What's that right balance? That's a time of consequence to figure that out. As far as contested environments, they now extend well beyond the battlefield to economic that imposes will before the forces are used. For example, critical materials, maybe some of you guys are tracking that. Denial of access is being strategically used by the PRC to influence our allies, impose market risk on U.S. investment, retard S&T, and attack readiness by owning the critical nodes in what is a highly optimized, thus fragile global supply chain. It is stopping us from innovation and stopping us to be ready. Finally, ascending domains. Interconnectivity implies there are not separate domains of air, ground, sea, and space anymore. It's just one domain. Again, those who have been watching in Ukraine, there's real battlefield demonstrations of this, and even how commercial can negate an adversary's numerical superiority and provide more rapid options and use of new ideas and technology than how we conventionally think of development. So each of these four embodies substantial challenges requiring S&T innovation, not just for the platforms in the field, but the entire process of ensuring we have a credible defense posture. But it definitely gets at asking the question of rethinking traditional process of discovery to deployment. Is there a more efficient way, more rapid, lower cost, and more transformational, not just evolutionary? So that's effectively AFRL's mission. We're here to win the future again and again and again by discovering, developing, and deploying high-impact transformative S&T across three epochs. So making a difference today when it matters, employing the smarts and the connections through the entire supply chain to put the technologies in the right place at the right time, to make sure tomorrow is ready and those acquisition programs have the technologies risk reduced in the supply chain in the next 2 to 7 years. And of course, ensuring that the future comes faster 8 years and beyond. So those time epochs and the discovery through delivery is a daunting 9-dimensional chess game. And that's what is the core of AFRL. We have 9 technology directorates that do everything from the critical components of foundational S&T, such as materials, human systems, information and sensors, weapons directorates that focus on kinetic and non-kinetic, as well as platform directorates that focus on air and space. We employ these to not only drive down risk and assess the states of the possible and champion development of ecosystems and supply chain, but we also create demos to show the game-changing potential. And those are some figures in the center. General Goodfellow mentioned a little bit of the X-58, the idea of having a loyal wingman and an autonomous partner between a drone and an aircraft. AFRL, if you noticed in this picture, that was the flag on the back of the X-58, and that is now a key part of numerous acquisition programs. The video on the bottom is Golden Horde. There was another demonstration from AFRL, which is collaborative munitions. So instead of one munition, one target, you can send out multiple munitions that collaborate amongst each other to execute the mission. And then on the top is rocket cargo, rethinking and redemonstrating how you deliver stuff to the fight. Instead of thinking of ships and air mobility command, large planes, how do you use rockets and the rapid reduction of cost of launch to be able to move things even more rapidly anywhere in the world? Those are all demonstrations that AFRL has done or are doing now, both for air and space, and ultimately for that joint fight. So what is the joint fight? What is the future? What do we need to worry about? What are you guys being asked to do? So how we think about that, the core components of a credible force and deterrence have remained little changed from time of Alexander and Caesar to Sun Tzu and Clausewitz. But really what has changed is it's how things are done. Across the top are the 5 key components of an OODA loop or a decision loop in the projection of force. I need to make sense of that information. I need to control my forces. I need to deploy my platforms, and I need to put energy on target. I need to do that with systems that are ready and reliable, and I got to do that from a point of strength or a home resilient base. Those are the components, like I said, that has been enduring for war forever. What has changed, though, is the multi-domain and the complexity. Now sensing comes from all places, space, air, ground. The data has to be fused. Decisions need to be communicated across too many different platforms, and they all need to be coordinated to deliver not just one effect, but multiple effects on target. And that really is it's called a kill web. And the whole goal is to execute our kill web faster and counter the Red's kill web. And that is the challenge that we are facing as the Department of Defense, as the Department of the Air Force, and as the bleeding edge of science and technology, which is how to insert new technologies that make this reality and change the game in the fight so that we have a credible deterrence. With that challenge aside, my question is, where do we look for the innovation to think outside the box, to turn the science fiction into science fact? And really, for me, it's movies and books. If I'm going to solve a problem that exists today, I need to talk to the people who have that problem, understand their requirements, understand their situation. But if I'm going to create the future, how do I figure that out? For me, I like the inspiration of science fiction paired with the question of, but what if? Hollywood provides the unattainium. As a scientist and an engineer, I want to know the unknown. And so I ask the question of, what's in the movies? What is real? What is possible? How do you get there? And the needs are not constraining. I believe the needs are the focus that's required to be able to take the science fiction and bring it into science fact. And so those needs are sort of on the right-hand side. How do we get inside that decision loop I talked about? How do I improve range and speed? How do I survive contested environment? How do I survive extreme conditions? How do I improve lethality? And how do I do it at affordable cost with mass and number, not just one exquisite platform? But then I need to worry about how I do it too. Interdisciplinary, I need to do it speed. I need to ensure there's trust. No one's going to use anything if they don't trust the system you've provided them. And I need to secure the supply chain. So let me give you some examples of actually that happening. And this is kind of fun. I owe this to a colleague of mine, Tim Bunning. He ran through this many years ago. But just taking ideas in Star Trek and asking, are they here today? Cloaking. We all remember cloaking from Star Trek, the Romulan ship just popping up right next to the Enterprise. But arguably, we may not be able to cloak a starship, but innovations in optical control, optical matter control, metamaterials, displays do give us, in essence, cloaking, the ability to hide things from multiple wavelengths. Teleportation, we're not taking full humans from one point to another, but we are transmitting information faster than the speed of light. That's quantum entanglement. Tractor beams, okay, so we're not grabbing ships, but interference of sound waves are allowing us to levitate materials and total new ways of assembly and manufacturing without physical contact, revolutionizing many aspects of assembly. And then, of course, photon weapons, the phasers. We have lasers, and the lasers are now ruggedized. And not only are the lasers being deployed in manufacturing, but they are a part of our weapon systems, not only for mission or fire control and targeting, but actually for developing effects, influencing the adversary so they can't execute their mission. This is what can be done today. So what are our Mars shots? What are we asking you guys to do? And this is really what excites me about the regional networks and the teaming that it brings together. I don't have those answers, but that's my challenge to you guys, because what we need, I won't say it's clear, but I think it's clearer than what we have ever had in the past, because we are catching up to the adversary. We know what the adversary can do, and we need to get in front of the adversary. But the technology and the science is still unknown. And so the regional networks were specifically scoped to accelerate this process by building on regional strengths, bringing all the innovative ideas that are in academia, small business, innovators, and industry to partner with AFRL F&Es who are working on the hardest of hard DAF problems that need science innovations. AFRL is very unique because it sits at that nexus of what is possible technologically versus what the DAF needs both today and into the future. And bringing that insight to innovators is really one of the key roles of the regional network. So I would like to congratulate the Midwest Regional Network for really proving out ways that we can rethink the partner and teaming to accelerate these emerging concepts in energetics, microelectronics, hypersonics, and space technology. You guys have showed how building symbiotic partnerships through early discovery, shared problem sets, complementary teams, and unique solutions. Those four things, bringing them together, is transforming the how. And it's foundational to our ability to respond in a time of consequence and to the challenges that I laid out. As General Goodfellow provided outstanding context, and he identified one of the major challenges we are facing as a nation. How do we harvest national innovation to solve these problems? And there are many approaches, many folks trying to tackle this from many different angles, such as his company. But I believe the regional networks are one of the key parts to become that whole that brings the ecosystems together so that we can more efficiently and effectively connect the problems to the innovators, no matter where they are, whether they're behind a fence or in industry or academia. So thank you very much for the time. Hopefully this has provided a little bit of context of why the regional networks are important and that we as AFRL committed to continue to engaging and leveraging them for the future. Thanks a lot and be happy to answer any questions.
I would like to thank you, Dr. Vaia, for your insight and your support today. I think you know, as well as everyone else that works with us, that we would not be where we are right now without you, and we really appreciate your time and your support.
Great organization. You guys are doing wonderful things, and looking forward to continuing to support and step back and watch the magic happen. Thanks a lot, guys.